Hi everyone, welcome back. So as promised in my last video, I am now going to talk about how massage can help in the relationship between mitochondria and metabolic fitness in the type 2 diabetic athlete. So if you have seen my video on the physical benefits of massage, you will know that it's actually been proven through research by a neurometabolic scientist called Tana Polsky that massage actually helps heal the body on a cellular level, even just after one session. And it was proven that through post-massage blood and muscle tissue tests, it was shown that there was a 30% increase in the genes required for mitochondrial development, which the mitochondria are required for cell growth and energy production. So really important for any athlete in particular. It was shown also that the lifting and kneading techniques of massage could also turn off the genes associated with inflammation, which, again means that massage will help improve recovery time after exercise or after injury, right down to the cellular level. And it's a valid treatment for pain and inflammation and for helping the soft tissues to recover. So I guess the first question on this video is what are the mitochondria? Well, basically the mitochondria is basically the energy powerhouse of a cell. They populate up to about a third of the volume of skeletal and cardiac muscle cells. So they really, hold a good proportion of the cell. Now, the mitochondria, as you can see, have various functions, from cellular respiration and energy production, to maintaining homeostasis, promoting cell growth, supporting the nervous system, and not only producing energy but also producing heat, keeping the body warm, and helping with metabolism of the body too. So why are these mitochondria so important actually to any athlete? Well, they have a fundamental role in athletic performance and endurance. They're responsible for aerobic energy production, which is required for any activity. They're responsible for also unconscious functions, so things like digestion, and even just the beating of the heart are kind of controlled by the mitochondria. Less frequent exercise results in actually fewer mitochondria in the cells, which means that then overall energy, coordination, overall fitness will suffer if the numbers of the mitochondria are reduced. Whereas regular exercise will increase mitochondrial production, which means in turn more energy production. So that's good news for athletes, because they're going to have the energy to get back out there and maintain whatever exercise program they're working to. But it's also important to recognise that mitochondria will behave differently in extreme conditions. So if any of you athletes out there are, maybe sort of working out or taking part in events that involve extreme temperatures, high altitude, or even fasting. And that could even come down to, sort of periods of fasting, maybe if you're a bodybuilder, and you have your sort of bulking periods and then your fasting periods. It will affect how, you fuel your body for different activities. So we're just going to look at some of those sort of extremes now. So starting with extreme temperatures. So if you are an athlete who is exercising, or as I say, maybe you're doing a marathon or something in either very hot or very cold environments, what happens is, this requires a constant energy output, whether it's, obviously hot environments, you're going to sort of tire more quickly. Cold, you've got that added sort of need to really keep the body warm, as well as just producing energy in general. So if you run marathons in, say, freezing temperatures, the mitochondria are not only responsible for producing energy, but as I say, they're also responsible for just keeping you warm. So that you're in a position to actually, move. High altitude. If you're doing altitude training, the mitochondria may well burn less fuel, or use a different fuel in order to maintain the blood's oxygen levels. Because as we know, at high altitude, you're more prone to getting oxygen deprived. So the mitochondria, will kind of adjust the way they work to accommodate that. With regards to fasting, nutritional factors are always going to influence, what fuel the mitochondria use. So, for example, during short-term fasting, fat is the sort of preferred energy source. Regular fat consumption combined with short-term fasting will over time increase the mitochondrial ability to use fat as a fuel. So how do they actually produce the energy in the first place? Well, basically they use calcium to turn the glucose in the blood into two chemicals, which alongside oxygen are used to produce ATP, or adenosine triphosphate, which is basically used to produce energy for the body. And it also enables the heart as well as the muscles to function. So this ATP binds proteins within the muscle cell, which causes the muscle to contract. So if an athlete is depleted of glucose or oxygen, or consequently ATP, then they won't be able to produce this energy. They'll have more difficulty in sustaining muscle contraction, and consequently their performance will be weaker. So oxygen is required for aerobic respiration within the muscle cells, and basically glucose metabolism, which is needed for this energy production and production of the ATP, is 13 times higher in the presence of oxygen. So this basically means that athletes really need to just be aware of things like heart rate, and again, if they're doing altitude training, because that will have a knock-on effect on how your body metabolizes the glucose and therefore the mitochondrial ability to produce energy. Exercise and massage will both increase mitochondrial growth within the muscle cells, which will therefore increase energy production and also cellular function. So how else can you increase the production of these mitochondria? Well, you can certainly encourage mitochondrial production by training well. You know, if you're overtraining or if you're training, you know, without allowing significant time, you know, for muscle recovery, you're going to damage the muscle cells, you know, which will then obviously affect the how the mitochondria sort of function. Hydration levels. Dehydration restricts the transportation of substances within the cells. So again, that could obviously affect metabolic processes within the body. Fuel. As we know, mitochondria require a steady supply of glucose in order to produce the energy that we need for training, and also protein for you know, for the growth of the muscle, but also for the growth of the mitochondria. So this means that athletes in general will need certainly high quality snacks to boost the glycogen reserves, and also a balance of carbohydrate and protein in their diet. Oxygen, you know, we've talked about a little bit, you know, that enables the aerobic respiration within the cell, and also is needed for the metabolism of the glucose, so which in turn produces more mitochondria. So as we said, athletes should be aware of their maximum heart rate to ensure that they have you know, a free-flowing supply of oxygen to the cells, so that this glucose metabolism can take place, and that, you know, you can get the energy that you need to do your workout. So I'm going to talk generally about the effect of aerobic exercise on the mitochondria. So the first thing to think about is aging. You know, mitochondria use oxygen and food to produce energy for bodily functions and exercise. And you know, certainly aerobic exercise, where you're really kind of, you know, bringing in that oxygen, can help to slow down any age-related, you know, mitochondrial changes. As you age, the body naturally makes fewer mitochondria, which then encourages the onset of diseases such as diabetes. But if you exercise regularly, or have massage regularly, you can actually double the mitochondrial production, which obviously is then can have, you know, really help boost your energy levels, and also to, you know, hold off these age-related changes. You know, if you stop exercising, normal levels will basically be reinstated within a month. So, you know, that can kind of revert back quite quickly. So also the shape of the mitochondria. Aerobic exercise increases mitochondrial volume, which enables the body to then repair itself more effectively after, you know, training or an event. Also, in terms of facilitating mitochondrial repair, So obesity and other chronic health conditions can cause cell death, but aerobic exercise will protect the body by restoring the balance of the proteins that are required for the repair, which are produced by the mitochondria. And obviously, obesity is fairly common in type 2 diabetics. So it's, type 2 diabetes, it's one of these chronic health conditions that can cause that cell death in the first place. So exercise is definitely, particularly important in the type 2 diet. And finally, mitochondrial cleaning. So when one of these chronic, health issues like diabetes is present, this can cause the repair system in the muscles and cells to fail. But aerobic exercise will increase the proteins that are required basically to clean the body and clean the cells in order to reap, the benefits of exercise. So how does all this, what does all this mean for the relationship between mitochondrial function and type 2 diabetes? Well, so impaired mitochondrial production in the muscle cells has been linked to insulin resistance in the type 2 diabetic. Now, those with mitochondrial disease that would have this impaired function, they may have symptoms characteristic of not only diabetes, but also autism, Parkinson's, Alzheimer's, Lou Gehrig's disease, muscular dystrophy, chronic fatigue syndrome, epilepsy, myopathy, fibromyalgia, and also developmental delay and some learning disabilities. So with regards to diabetes and mitochondrial dysfunction, type 2 diabetics not only have less mitochondria, but the mitochondria in these clients are also smaller and less efficient and so, this is going to obviously affect cell function and also energy production. So the mitochondria promote insulin release from the pancreatic beta cells, which is required for the production of the ATP, which is used for energy. So mitochondrial disease, therefore, has been suggested to be a cause of abnormal glucose metabolism and consequently energy levels. Type 2 diabetes, as we know, is becoming more prevalent because of our sedentary lifestyles, poor diet, which results in obesity, which further affects the insulin production and release. So, just to recap, mitochondria produce adenosine triphosphate, or ATP, which is required for energy. The mitochondria also regulate glucose-stimulated insulin secretion in the pancreatic beta cells. Mitochondrial function is closely linked to diabetes due to pancreatic B cell dysfunction insulin resistance, and obesity and other vascular complications. So, what are the causative factors of mitochondrial dysfunction in diabetes? Could be genetic factors, environmental factors, certainly obesity, which we've mentioned, which again is common in type 2 diabetics, but also something we don't hear about very often, which is intrauterine malnutrition. So basically means that poor nutritional status during fetal development can actually permanently alter glucose insulin metabolism, and also protein malnutrition can impair the pancreatic B cell development and impair insulin secretion. So all of these things are going to affect how the glucose in the bloodstream is metabolized, and therefore how the mitochondria can produce energy, which is then needed for you to work out and exercise and further improve mitochondrial development and energy production. So how does massage? We know that massage has a similar effect on the mitochondria to exercise. How does massage affect the mitochondria, energy levels, and therefore ability to exercise in the diabetic athlete? So massage has been proven to increase the gene needed for mitochondrial development by 30%. That's going back to the research we initially mentioned by Tana Polsky. This then promotes cell growth, muscle function, and energy production. It helps to reduce inflammation and recovery time, because the increased mitochondrial development also then produces the proteins required for muscle recovery. Recovery time following exercise and injury, right down to a cellular level, will be improved. Massage also helps to compensate through increasing the number of mitochondria. It helps to compensate for the fact that the diabetic athlete will have smaller and less efficient mitochondria. We know that overtraining and, training, before the muscles have had a chance to recover properly after injury, we know that this is going to damage the muscle mitochondria, which will then impact on energy levels and muscle function, and also glucose metabolism, which is needed, for the energy production. And so by having a sports massage to maintain muscle strength and flexibility and help the muscles recover, and therefore reduce the risk of further injury, this means that the muscles are then ready to exercise again, which in turn will hold off those age-related mitochondrial impairment, which can cause the chronic disease such as diabetes and prevent obesity, both of which can further impair the mitochondrial production. And obviously we know obesity is common in the type 2 diabetic, which again can cause mitochondrial death. So by boosting the mitochondrial growth and production, massage can also help regulate the glucose metabolism. And in doing so, the glucose is needed for production of energy, and it can also, help regulate this glucose metabolism by also promoting the release of insulin from those pancreatic beta cells. So it's all kind of a bit of a cycle, kind of by, what I mean by that is by improving the mitochondrial growth, you're helping with the metabolism, you're helping then with the energy production, which allows you to exercise, which then helps to further increase the mitochondria production and helps to, sort of steer clear of these chronic diseases, steer clear of the obesity, which will cause the mitochondrial death and therefore reduction of energy. So one thing kind of leads on to another. So so that is how massage and exercise will help not only with the mitochondrial health, but also help with the metabolism and energy production of any athlete, but particularly, in a type 2 diabetic athlete, where obviously there are issues with the glucose metabolism. So I don't think there's much more I can say on that subject. If you have any questions, as always, leave a comment down below. Contact me through my Facebook or Instagram pages, and you can subscribe to my channel so that you get notified of any new videos coming out. There will be quite a few more sports related, certainly posts coming. Until next time, that is all from me. So see you next time. Bye.